So, hello everyone, my name is Arpit and we are learning Java. In this lecture, we are going to learn Java JVM Architecture. What is JVM? You already know that Java Virtual Machine. Suppose we have a conference hall or anything, we have a hall. Suppose that there will be a performance of a magician in this hall. So, this hall will be divided in three parts. First part is for the magician. Second part where all the reserved seats, whoever have bought the ticket, will will gonna sit this. And the third area, this third area, which is already blank, which means that in between the show, uh, if someone wants to come and watch the show, can be sit here. This is the stack of chairs which can be present here if someone comes at the end. So there are three spaces. One is already reserved for the magician. Second is reserved for the people who have bought the ticket. Third is unreserved. Whoever comes in between can sit here. Similarly, JVM have this structure like in this place, it is already booked for the magician. This is a booked space, and this space is for the people who will come at the end. In JVM, there are these three spaces. The second one is stack, this one is heap, the first one is the area where the code is getting to stay. So now, let us explain with the example. In this question, there are imported classes like scanner class. There is a class named addition, main method, scanner class. These are the literals, string literals. Num1 and num2 are variables. These are some. Suppose the class name is addition dot java. It will compile to the addition dot class. So, or this will go to the memory in the code section. In the code section, and the process is called loading. In Java, all are present inside the class. So this is called class loading. This is called class loading, and this process is done by class loader. So we have learned that this is the class loader which loads our program into the memory. So in the code section, all the code is present here. In stack, what will be coming inside the stack like variables like num1, num2, sum. Here you can see that the println, it is a method. It will come inside this println scanner, reference to which this scanner class. So this will come inside the heap memory. And the reference of this scanner is present in the heap. So this is how our program is stored inside the memory, and all this is processed by CPU. At the end, CPU will be start executing this program. This is the byte code. Our CPU does not understand byte code. It will be converted in machine code. Who will convert this in machine code? Interpreter or JIT compiler. which is already present inside the JVM. After this execution, we will get our output. So now we are going to see this in detail. We have already talked about the class loader. You already know what class loader do. So this is the JVM memory. Inside this, there is a method area which we have already called about the code section, the stack section where all the reserved are kept here, and the heap memory where unknown which are not reserved are kept here. This is the execution engine. This contain interpreter, JIT compiler, and one more thing, garbage collector. What is garbage collector? See, in the heap memory which are not reserved, if someone wants to leave the show in between and there will be an empty space, so this empty space will be collected by our garbage collector, so garbage collector collects all the garbage which are left over in the program. We will see the garbage collector more in future classes. Now we have some other things like PC registers, native method interface, native method libraries, native method stack. CPU stores the address of the next instruction. CPU is responsible for the execution, but not directly. In between, there is a JVM role also, and all these are the basic component to execute the files. So, what do PC registers do here inside the JVM? While executions, CPU already have registers, but if it needed the registers more, then it is already available in the JVM. JVM always interferes in between the execution and the CPU. In lastly, in Java, we can call the native methods of C and C++ in our program. Those methods which are of C and C++ which can be called in our program are native methods. This is a native methods library which is already present inside our JVM. Why they are called native method? Because they are platform dependent. That's why they are called native method. So if those methods were called, they will have their separate stack and the interface between the Java program and the C++ program. This section is present inside the JVM, but you can consider this outside our Java program. You can consider this section as an external Java program, but JVM is responsible for this. That's why they are present inside the JVM. That's all for now. I will see you in the next class. Thank you.